Okay, today I'm going to talk a little bit about my bin-jam project and specifically what I think of as the long-term version of this project after spending a few days analyzing the results and sort of thinking ahead about what this project would be about if I kept going. So, first thing I've thrown up on the screen here is just a description of the project and what I think the main question is that needs to be answered to get the project started. So the goal of the project at this point has become to create a reusable core for visualizing binary formats. And what I mean by that is, in the way that 4Coder had a reusable core for creating text editors, I'd like to do the same thing for visualizing any type of binary format. A difference from the 4Coder design to this one is that it's not going to be a customization layer that is monolithic, that defines the whole thing. It needs to be a composable plugin system this time, because we're going to have to support lots of different formats, right? And so I don't necessarily want to have to switch out which format a process is supporting by switching to a different customization layer over and over again. I want to be able to mix and match all the formats that are relevant to me, which will require these things to compose cleanly as plugins. And so the plugins are going to be the thing that take in raw data and construct something I'm calling binviz for now, just a stand-in type name for whatever that will be, some kind of structured information about the data. The core's job is then to take the binviz data and create a user interface. So this is where the user has, the writer of the plugin has the privilege of not having to think about the same thing every time they make a new format visualizer, and the user gets a consistent user interface. So that split there is designed so that we can put all of the UI stuff, all of the visualization primitives into the core, and the plugins just get to parse their data format and declare the visualization structures that need to be used. The core would also be responsible for a system for managing plugins, having various user config stuff, and acquiring the target data for these plugins to consume. And then the big design question here, as I was saying, is what is this binviz structure going to be? All right, so on this slide, I'm showing the analysis I get when I look through all the code that I wrote for the Handmade Network Jam and pull out the data structures that are being used there as intermediates and use that to define what binviz would be if it had actually existed as a singular centralized concept in that code, which it doesn't, but conceptually it could have. So at the root level, the binviz contains the raw data, which gets used for the hex view, and it remembers the name of the file that the data was loaded from, and then it has this tree that sort of marks up the data. And the tree is defined as containing a list of its children, right? So it's an arbitrary number of children per node kind of tree. It's a loose tree, not like a binary tree or something. We keep track of the depth of each node, so we know how deep it is. We have an index, so as I'm going, the root is a 0, and then the next thing is a 1. Its first child is a 1, and its first child is a 2. So if you were to sort of unfold the tree in depth first order and index all of the nodes, that's what you would get. The trees each have a string attached to them. It's like the text on that node, which can be used for labeling it in a UI. They can optionally have a table attached, which is a sort of a separate data structure that's defined over on the right. Basically, you think of like a set of columns with labels and rows for each record in the table kind of table. And then it can also have a range attached to it, which is a range within the raw data where this particular node in the tree represents. So for instance, if I have a header, then the range of data inside the hex that is that header gets marked up by having a tree node and giving it a range like this. And then you can see on the right the table as I described. There's some, we don't have to go through the notation, but that's, it's a table with columns and rows, right? The point being, these are the data structures that are underlying the current interface that I have. And so next what I want to do is spend some time thinking about visually, from the visual side, what interfaces I might like to have, also interactively what interfaces I might like to have. And then over time, as I implement some of those, work on this data structure definition. The data structure definition is important and needs to be well designed, but it also needs to match up with what interfaces I want. So let's go through some of the interface ideas that I don't have support for in the prototype that I'd like to explore more. So first of all, if you haven't played with the prototype or seen any screenshots, this is what it looks like right now. There's these sort of three columns. On the left side, there's the tree view, so you can see whatever part of the tree you want, and you can fold and unfold the folders and select one of the nodes in it. In the middle, there's the hex view, which is just showing you the raw data as a hex editor would, basically, but it's not editable. And then on the right side, there's a main view where, in theory, any arbitrary sub-UI, extra UI could show up. Right now, that just shows a data table whenever there's a data table attached to the currently selected tree node. So one idea that I'm itching to explore is this idea of pointers. So in binary files, there are concepts like pointers, but they're actually more interesting and intricate than what pointer means in the C language, because there it means sort of an address at the lowest level, what the CPU considers a memory address. But here in raw binary files, it can mean offsets from the base of the file. It can mean offsets relative to the location of the current pointer. It can mean indexes into tables. There's lots of ways that binary data references other pieces of data. And so I think it's interesting to be able to visualize where a piece of data is referencing other data. And so I have some ideas here about, I want the affordance to be able to put a box around a piece of data in the hex view. I want to be able to ask for these arrows to represent pointers between things to be rendered in an easy sort of way. I want to be able to mark up those boxes with sort of color or icon or something so that I can have sort of invalid pointers. So from this view, what I'm kind of looking at is the idea of pointers in the hex view could be implemented with some of these visual capabilities. And then I'm breaking that down. It's like, okay, these are three different things I might want to go and implement and see how I could model putting these things onto the data in the binviz data structure. Another piece of the interface that I definitely want to support is a sort of file-wide search. So for that to make sense, somehow an index needs to get generated with all of the searchable key phrases and the entities that they link to. And somehow we need to define this idea of what a link is going to be. So on the structure side, there's this interesting question coming up of if I have a data structure called binviz that contains a tree and it can contain subtables and it might contain now like a list of pointers or something, like I'm not sure how that fits in, if it's a part of the tree, if it's its own data structure, right? But as this data structure called binviz gets more complicated, what a link consists of is it's somehow got to be able to point to various different points of that data structure. And so what are the different places I want to be able to point to in the data structure, and how do I want to represent all of those in a uniform data type, right? That's one of the questions I'm now thinking about, is how am I going to construct this link data structure? And one way to do it would be to push the data structure to be more homogeneous, right? If the binviz was more homogeneous, links get easier. They become more and more just like addresses or pointers. If there's a lot of heterogeneous data structures kind of pieced together, then the path from sort of the root the root of the coordinate space, the 0 point, to one of those data structures can become more and more convoluted. So I want to think about how to avoid that getting out of hand, but maybe not hamstring the data structure to being perfectly homogeneous. How could I do that? Is that even something I want to do? What's the right trade-off there? Also, obviously, for things like search, I'm going to need another affordance in the UI, which is sort of a drop-down transient interaction mode or system. And there's this interesting problem that comes up that has a lot of solutions, and none of them are quite perfect. But it's worth thinking through, and that's how am I going to paint ranges onto the hex viewer, right? Or to put it more specifically as a data structure problem, if I have this data that I can put into a hex view, and I have a set of arbitrary ranges that got produced by the plugin, right? Because we're going to have these plugins take in the raw data and generate the binviz data structure in one way or another. Every range that I want to paint is somehow going to be, and when I say paint, what I mean is like color or mark it or somehow make it visually obvious that there's a range there. How can I take that arbitrary set of ranges and over that data and turn it into graphics in a way that's going to work in lots of useful ways, right? There's a lot of ways I could do that. What are the useful ways? How can they combine nicely? That's a part of the question. So like one idea is to be able to put things in boxes. We already talked about boxing with the idea of rendering out pointers. So if I could keep going, what if boxes could nest? That would help with some sorts of arbitrary ranges like trees when I have a section with sub data pulled out of that section and I want to mark it all up that way. But some ranges would be overlapping each other, right? So this happens when you have markup that comes from things like there being a range that contains an error, which happens to overlap a data section or things like that. It's not as common if you're only thinking about your ranges as being the markup for well-parsed data. But, even if it's just because you have a bug in the plugin, you might still want to have a nice, clean way of seeing that there's an overlap, right? So I don't want to just rule out non-nesting overlaps, sort of straddle overlaps like what's shown here. And so there are pros and cons. You can't nest them. And so you'd have to have some way of figuring out when nesting does and doesn't apply. And there's a limited amount of space for nesting in the visual layout of things without having to start spreading out the hex in complicated ways. So I'm not entirely sure if I can do nesting, but that's an idea to explore. There's also underlining, has very similar properties to nesting. It runs out of space at a certain point, so you can't do an arbitrary amount of it. But it could be a useful tool. I'm not sure if it can be done together or how that would exactly work. Like if maybe the layout could account for up to 1 or 2 colors of underline and then have the boxes. Would there need to be some kind of coordination between the different users of these things so that like things which want underlines declare themselves as wanting underlines and things that want boxes declare themselves as wanting boxes? Or do they represent different ideas maybe? I don't know. I don't know how they would stack on each other is the main point. Another possibility for any of these when I'm trying to figure out how to make the decision about how to paint each thing visually is to just say that there's a priority order. So even if you paint the same cell multiple ways, if you have like strictly nested boxes, maybe we always have the smallest box in the nesting. And if you have straddle overlaps, then maybe there's just a rule like whichever one was declared first, in the order of the parser, not in the order of top to bottom through the file. Or there could be different rules for how to decide the priority of these things. I'm not sure. Then there are just other visual ideas. Instead of boxing these things, I could sort of color them, maybe give them background colors and have those have the ability to be striped, maybe as like stacked boxes in each cell. It could also be sort of like diagonal stripes or something, or a checkerboard or dithering pattern, something to put multiple marks side by side on the same cell. It's interesting. I don't know if that's a good idea, but it might be fun to play with and see how good it can get. I imagine that would get visually complicated with more than like 2 or 3 colors too. So again, not sure if that's the right solution or even one that I want to keep, but it's an idea to explore. And another possibility is to not mark up the hex directly, but to do something like margin gutters. Or margin, like stuff over in that gutter over there, or the margins, like you have like stripes that color up ranges, and that gives you the ability to sort of make that wider or narrower so that you can fit more close to an arbitrary amount of data in there, I think, but it's not directly mapped onto the hex. Those could also be combined so that if you hover a stripe, it then does a box or an underline or something like that. So there's possibilities for how that could be useful, and this could also be paired off with the tree that probably contains some of these ranges, but maybe not always. So there's like different ways we get these sets of things that want to paint the hex. And depending on where they come from, they might correlate with another data structure like the tree. And then, there's some interesting overlap between these ideas and a mini-map view. So this is one that I want to spend some time exploring as well. Another big question that I think should be looked at whenever I'm thinking about visualizing things is what about diffs? Diffs are a really useful kind of visualization. And visualizing binary data is already hard enough, but visualizing a diff between them is impossible. And so it'd be cool to have something like a general solution to that. And so one possibility is to just say our plugins can also supply a data cross data type. So if you put in 2 files that are supposed to be the same format and you have a plugin for that format, then if it implements the conversion of a pair of inputs to a diff visualizer, then you could view it. But that would mean that anytime you have a new format, you have to implement 2 of these functions, right? You have one that implements the bin viz by itself, just input a single data file and visualize it, by constructing the binviz structure, and then a second function has to go with that plugin if you want the diffing. And so it's possible maybe to factorize that into having the plugin run on both inputs separately, and then actually diff the binviz data structure to create this diff view. I'm not sure if that's possible, but it'd be interesting to explore that. So that's a research question I might like to get into at some point, which is if we start building plugins like this and the binviz data structure is properly understood so that there's a way to diff it, could we have the core provide the diff and you just provide a plugin that does the thing I originally talked about for visualization and then run the diff on that part to get a good diff? Well, I don't know if that would be good, but it might be, and that would be interesting to explore. A couple other research questions that I am thinking about here are, what about inputs of files or inputs of source data that are not just a single file? So for instance, with a debugger, you end up kind of synthesizing information from a PDB and an executable and all the source files simultaneously. And so some visualizers for, the PDB exe source file complex might want to be able to depend on more than one input. Similarly, if you are trying to visualize data going over like a packet stream or socket or a pipe of some kind, that might be the kind of thing you also want to be able to look at, and how would that fit in? And I think it might be necessary to say, hey, we don't just want a data type, like a raw data blob, to be the input to these plugins. Maybe we want something with a little more structure, sort of like a set of labeled pieces of data that can be understood in different ways. I don't know exactly what's appropriate and how far you want to go there in terms of structuring the input for the plugin, but it'd be worth exploring possibly options beyond just single data blobs, so that these other kinds of scenarios that come up pretty frequently could also be captured in this tool. So that's sort of my thoughts based on what happened in the jam and what I came up with and what it felt like it was capable of becoming. And those are the things I'm going to be exploring. So a lot of that is development stuff, which is just to say there's not big research. It's very practical. Like, can I put the colors on the hex view in the way that is most ergonomic or most visually pleasing and useful, most interactively useful? So I think that could take some time to build out. And there's also questions about, like, if a tool like this were to exist, what kinds of views am I skipping over? Do I want just like a text buffer view so I can look at text files and disassemblies and stuff like that? Do I want other kinds of views besides the table and the tree that I'm not thinking of off the top of my head? Like, maybe I want to be able to see a bitmap or 3D geometry rendered out. Do I need plugins for rendering out things like that are separate from the data structure or the format parsing plugins? And there are other questions that I haven't fully thought through yet, like how would you use a parser that you wrote for this to test another parser, right? If you have a really good implementation that thoroughly parses your file format and gives you a visualization of how your parser is behaving, that's cool, but that's a parser that does a whole lot of work. Right, that parser is marking up the stuff it's generating is a lot more detailed than what a really fast parser in a runtime would do, right? So like if you have a asset packing format and it's compressed and archived and it's in some useful way for your data to ship with, and you want to be able to look at the details of your file, then you would put it into a parser like this. But if you want to load it into the engine of your game at runtime as fast as possible, you would probably want it to not be factored as reusing the same code as the data plugin. So that's useful, that's fine, you can do it that way, but then you're going to end up writing multiple parsers. So it might be useful if you go and invest in building one of these parsers for the bin visualization purposes, if that parser could then be reused as a sort of testing point. If there's a short distance between that and a tester that says, hey, your parser is generating the right data, for your other parsers, your faster parsers are generating the right outputs by comparison to whatever the sort of fancier, more canonical parse says, so that you have some way to keep them in agreement with each other. I could imagine a number of ways that could be built out, but I think that's a little farther off because it might be too much of a reach from what I've got here. So I don't know. I'm excited to explore a lot of these possibilities, and this is the research project that I think I'm going to spend a good while on now. It also is nice because it ties back to my last two projects. One is it allowed me to test the Mr. Fourth base sort of modularity problem. I've been upgrading Mr. Fourth base to get ready for that to come out someday. And something I didn't have was a real project that needed to have DLLs cooperating across a boundary, but all sharing the same base layer. And so this will give me a reason to actually build a system that will do that and see how it works. And this will also allow me to go farther with visualizing the objects and image files that I was visualizing when I stumbled upon this idea. So I think it puts together two of my research projects nicely, and it makes for a nice tool project that could actually come out and be a useful thing to build along the way. So that's where my attention is going to be going for now. And if you have any thoughts or questions or other things you'd like to point me to that are similar, go ahead. I think my next big step is actually going to be to go and do a series of explorations of prior art similar to this idea. So you'll be able to check that out on my Twitch streams and maybe on here a little bit, depending on where I decide to publish that piece of the work. All right, so probably there'll be an update on this sooner or later. And until then, I'll see y'all around.